Imagine driving beneath the ocean floor. Above you, container ships. Beneath your wheels nothing but concrete, steel, and precision, holding back an ocean that could swallow a city in seconds. One failed seal. One unnoticed crack. That's all it would take. For decades, engineers said this belonged in science fiction, not one of China's busiest marine corridors. Yet today, thousands of drivers cross it daily without a second thought. So how did China pull this off? Not bigger machines, not more concrete. The real challenge was hidden somewhere no satellite, drone, or human eye could see. Not in the ocean above. In the ground beneath it. The Pearl River Delta had become one of the busiest economic engines on Earth. Shenzhen's tech and manufacturing power on one side, Zhongshan's booming but cut-off industry on the other. A trip that should take minutes took nearly 2 hours, bleeding the region billions a year in time, fuel, and lost business. The obvious fix was a bridge. That's exactly where the trouble started. The Pearl River estuary is one of the busiest shipping lanes in China, and a bridge tall enough to clear that traffic would threaten shipping, aviation, and the ecosystem around it. This wasn't a bridge problem anymore. It was a puzzle with no clean answer. Longer bridge, higher cost. Deeper tunnel, more pressure. New route, more damage. For years, the project stayed trapped between ambition and reality. Then someone asked a question that sounded almost reckless. Why not build both? A bridge and a tunnel, fused into one crossing. That single decision would define the entire project, and hand engineers a problem many believed simply couldn't be solved. What was actually waiting under the estuary? Not bedrock, not a buried mountain. That would have been the easy version. Instead, soft marine clay, loose sand, ancient sediment, and fractured rock, compressed for thousands of years. Engineers weren't building an 8-lane highway on solid ground. They were building it on top of a giant underwater sponge. A tunnel is only as strong as the ground holding it up. Let the seabed settle unevenly by even a few centimeters, and stress starts climbing inside the structure, quietly threatening every seal and joint for decades to come. Before a single machine showed up, the first fight was fought with data. Survey ships mapped the seabed for months. Drilling rigs pulled core samples from dozens of points below the surface. Some spots looked solid. Others hid pockets of sediment waiting to give way under enormous weight. There was a second problem that had nothing to do with soil. This stretch of water never stops moving. Container ships, oil tankers, cargo vessels. Shutting the route down wasn't an option. Whatever China built had to vanish beneath the ships, not compete with them. That's the moment the bridge-only plan quietly died. The tunnel wasn't a backup to the bridge. It was there to protect one of the busiest maritime corridors on the planet. The question became how to build beneath an active shipping lane without ever shutting it down. Even the most experienced engineers on the project admitted there was no room for error. The price tag and ambition turned it into international news. Supporters called it proof of what Chinese engineering could achieve. Critics called it reckless, a budget and risk profile nobody could justify. Some analysts went further, warning the tunnel would push marine engineering to its absolute limits. The debate stopped being about concrete. It became a debate about national ambition. The engineers didn't have time for headlines. After years of surveys and redesigns, planning ended, and the first tunnel section had to actually get built. Here's the twist almost nobody expects. It wasn't built underwater at all. A structure that would live its entire life under the sea, built entirely on land. Picture the world's largest puzzle, each piece longer than 2 football fields, weighing more than 80,000 tons, and each one had to lock into place underwater with almost zero margin for error. Engineers built massive dry docks along the shore, underground factories casting each segment under tightly controlled conditions, sealed off from waves and weather. Each finished section carried 8 lanes of traffic plus maintenance corridors, emergency routes, utility lines, and full ventilation. This wasn't a tunnel. It was a self-contained underground city block. Then came the part that sounds almost unbelievable. Workers flooded the dry dock and let an 80,000-ton concrete structure float, like launching a building as a ship. Tugboats towed it across one of the busiest waterways in China, timed against currents, wind, tides, and live traffic. One bad weather window scrubbed the operation. Once a section left the dock, there was almost no turning back. Lowering it wasn't the hard part. Landing it was. A trench had already been dredged across the seabed, waiting. Using GPS, lasers, hydraulics, and real-time sensors, engineers guided the floating giant toward the bottom, a descent that took hours, where a single meter of error could ruin months of work. Not because the machines lacked power, but because at that depth, precision mattered more than speed. Picture trying to park a moving train while blindfolded, on a track hidden under dozens of meters of water. That's the accuracy they were chasing. Then came the moment nobody wanted to get wrong, sealing the new section against the one already resting on the seabed. Massive rubber gaskets compressed between them, and hydraulics pulled the two pieces together until they behaved like one structure. Only when the seal held could engineers finally breathe again. But here's the catch nobody warns you about: nailing one connection didn't guarantee the next. A tiny misalignment today could snowball into a serious problem weeks later. That's exactly why the earlier obsession with data wasn't overkill. It was the only thing standing between success and disaster. Just as the process found its rhythm, the ocean reminded everyone who was really in charge: tidal surges, sudden weather shifts, zero visibility, non-stop ship traffic. Some installations got delayed. Others were adjusted mid-operation, with no room to improvise. Building this tunnel wasn't just engineering. It was a negotiation with a force that refuses to negotiate. While every engineer's eyes stayed locked on the sea above, a second threat was already waiting beneath the tunnel, silent, invisible, capable of undoing everything they just built. By the time the last section locked into place and the concrete cured, it looked finished. Cranes gone. Equipment cleared out. Job done, or so it seemed. For the engineers, the real pressure actually began here. A bridge can close a lane for repairs. A tunnel under the sea doesn't get that luxury. Every system inside had to work flawlessly from day one, because fixing anything hundreds of meters underwater is a different kind of nightmare. Before a single driver was allowed in, the tunnel went through months of brutal testing. Every joint was checked for the faintest trace of water intrusion. Sensors tracked movements measured in millimeters, numbers that sound trivial until you realize they're the exact warning signs of a failure decades away. Every survey, every simulation, every obsessive alignment check from years earlier was insurance against a disaster that might not surface for 30 years. Water wasn't even the scariest threat. Picture thousands of vehicles moving through a sealed concrete tube every day, then picture one catching fire. Smoke behaves differently underground. Heat builds faster. Visibility vanishes in seconds. Panic spreads faster than flames. Long before opening day, engineers forced themselves to answer one brutal question: what happens on the worst possible day? Every part of the design answers it. Powerful ventilation systems yank smoke out fast, emergency passages give people a way out, and fire-resistant materials, detection systems, backup communications, and redundant power all exist for one purpose: making sure one bad incident never becomes a catastrophe. Then there's the enemy no design can fully tame: nature itself. Tides rise and fall twice a day, seasonal currents reshape the seabed, typhoons slam the surface with unpredictable force. This structure doesn't just need to survive today's conditions, it has to survive decades of shifting sediment and relentless traffic, with zero excuses. That's why thousands of sensors work right now, hidden behind the walls, tracking movement, pressure, temperature, and water intrusion around the clock. If anything drifts past a safe threshold, engineers know before a driver ever feels it. In many ways, this tunnel never actually stopped being built. Construction ended. Monitoring never will. People remember the cranes, the ribbon cutting, the headlines. But the real test of a megaproject isn't opening day, it's how boring the next 50 years turn out to be. And even after proving it could survive the sea, one question refused to go away, louder than any of the engineering triumphs: was any of this actually worth $15 billion? Supporters called it a once-in-a-generation bet that would reshape one of the most productive regions on the planet. Critics called it a staggering price tag chasing a risk nobody could guarantee. Some argued a simple bridge should have been enough. Others said the money belonged somewhere safer. There was no easy answer. Only two sides that refused to budge. This was never really a debate about concrete. It was a debate about what a country is willing to gamble on. Then the Shenzhen Zhongshan Link actually opened, and the argument started to shift. A 2-hour crossing collapsed into 30 minutes. Commuters got their evenings back, manufacturers got faster deliveries, and suppliers, workers, and customers once separated by a bay were suddenly neighbors. Every day now, thousands of vehicles cross a route that didn't exist a few years ago. Will it fully pay off? That answer won't show up next year, or even next decade. Projects like this get judged across generations, not headlines. But one thing is already undeniable: this tunnel didn't just connect two cities. It rewired how an entire region moves, exactly what its designers hoped it would do. The next driver crossing this estuary won't think about the invisible mud, the blind descents, or the concrete giants lowered into darkness. That's the real achievement. The impossible vanishes not when people stop talking about it, but when it quietly becomes part of everyday life. Until someone proves otherwise.